Okay, I just want to go over the degree and leading coefficient for polynomial functions. And just to recap, the greatest power of x in a polynomial function will represent the degree of that function. So if you look at example 1a here, the highest power of x in this case is 5. So this would give us degree 5. Then when we look at the leading coefficient of a polynomial, what we're talking about now is the numeric coefficient of the power, the highest power of x. So in this case, the leading coefficient would be -2. So let's see if we can try another question now that we've determined the degree and the leading coefficient of example 1a. Okay, in example B here, we have another polynomial function, and I think it's easy to see that the highest power of x in this case is this term. So this would be a degree 2 polynomial function, and the leading coefficient, I'll just call it LC, would obviously be equal to +5. Okay, let's try one more here. I'll just make one up on the fly. How about if we have functions such as f of x equals x to the 4th divided by 3 minus 3x cubed plus x minus 6. So this would indeed be a polynomial function because it has containing all powers of x, and they're all the exponents are whole numbers. And it's not hard to see here that the term that contains the highest power of x is this one right here. So this would give us a polynomial function of degree 4. And the leading coefficient may not be as obvious. Technically speaking, that would be 1 divided by 3 as the numeric coefficient. So the leading coefficient here would be 1/3. So I hope that helps you understand just the concept of degree of a polynomial function and the leading coefficient, which will be very important as we move through this unit.